All right, welcome back to the deep dive. Today we're skipping the manual and going straight to the core of this little box here. It's the NTI ST-IPHD-LC-V4 HDMI over IP network extender. And our mission really is to figure out how this pretty low-cost device, uses standard network gear to solve a huge problem, like running a campus-wide digital signage network.
Exactly. It's all about using what you already have, right? Your standard under 1,000 base T gigabit network. You don't need some special expensive cabling for this. It just takes that digital video and audio signal and this is the key word here, it multicasts it.
Multicasts. So it's not sending hundreds of individual streams.
No, it sends just one stream that all the receivers on the network can listen to. I mean, it saves a massive amount of bandwidth.
Okay, so let's get into the numbers then. What are we actually looking at performance-wise?
You're getting full HDTV, up to 1080p. And the range is, well, it's pretty impressive for standard copper cabling. About 120 meters on good seat 6 or 7.
Okay, 120 meters. But what if a campus building is, much bigger than that?
Well, that's where it gets really clever.
Yeah.
You just cascade standard network switches. So that distance isn't really a hard limit. You can extend it almost indefinitely, just going from switch to switch.
I saw something in the specs that caught my eye. It says HDMI 1.3 and HDCP 1.4 compliant. Why should someone planning a big installation care about those specific versions?
The HDCP 1.4 part is the digital rights management piece. It's essential if you're trying to show encrypted commercial content. Basically, it means you won't just get a blank screen.
So it just works.
It just works. And on the efficiency side, it uses H.264 compression, and the latency, the actual delay, is listed at less than 100 milliseconds.
Which is basically nothing. To the human eye, that delay is imperceptible.
Right. You'd never notice it. And the physical side of it is also a game changer. These units are tiny, and the power draw is just incredibly low.
How low?
The local unit is 2 watts. The remote one is even less, 1.85 watts. Think about the operational cost savings when you have thousands of these running.
That's incredible. But I did see one constraint. It has to be a local area network, a LAN. It won't work over the wider internet.
That's the one big limitation, yes.
Yeah.
It's designed purely for internal distribution.
Okay. So the specs are impressive, but the part that really stood out to me was the whole network management side of it. It can do a simple point-to-point, but also that complex point-to-many setup.
Right. And for a simple setup, one video source, many screens, you don't need anything fancy. A cheap, unmanaged network switch will do the job perfectly for, up to 253 receivers?
Okay, but let's complicate things. What if I have 3 different simultaneous video channels running, channel A, B, and C? The notes say you absolutely must have a managed switch for that, and those can get pricey. So are you just trading one cost for another here?
That's a really sharp question.
Yeah,
But no, not really. The cost of that managed switch is what makes this whole thing scalable and manageable. It's all about segmentation.
Segmentation.
Yes. Specifically, you need a switch that supports port-based IEEE 802.1q VLAN technology.
VLANs. Okay, break that down for us. What does that actually do for the person watching the screen?
Well, think of it like this. The physical network cable is a big highway. Without VLANs, all the video traffic from Channel A and Channel B and Channel C is just one big traffic jam waiting to happen. What a VLAN does is it creates separate, dedicated lanes on that highway for each channel.
Ah, I see.
So Channel A's traffic can never accidentally spill into Channel B's lane, even though they're on the same physical wire. You assign one transmitter to one VLAN. It's software-defined separation. It's the core idea here that lets you replace a giant, expensive hardware matrix switcher with software logic.
So wrapping this all up, what's the big takeaway? It sounds like this device offers a really flexible and extremely cost-effective way to push HD video over the infrastructure you likely already own.
It really does. And it leaves you with a really interesting question to think about. Considering the device's minimal power draw, under 2 watts a unit, and the fact that you can cascade these switches pretty much indefinitely, what are the total strategic cost, energy, maintenance, everything for running a massive, maybe even continent-wide digital signage network built on this? Especially when we compare it to the older proprietary, much more power-hungry technologies, it really transforms that whole conversation around capital versus operational expense.